Can robotics deep learning overcome huge data needs? Imagine teaching a robot to pick up objects or drive a car without spending hundreds of hours collecting data. That's the challenge deep learning faces in robotics. Deep learning models, which are neural networks with many layers, are great at finding patterns in data like images or sensor readings. But they usually need enormous amounts of labeled data to work well. Gathering this data in robotics is tricky because it involves real-world trials, which are costly and time-consuming. For example, training a robot to grasp objects might require tens of thousands of successful attempts over many hours. Autonomous vehicles need millions of miles driven in different weather and traffic conditions to learn safely. This huge data need comes from the fact that robotic environments are unpredictable and complex, so models must learn to handle many different situations. To tackle this, researchers are trying several smart strategies. One is simulation, where robots learn in virtual worlds that look and behave like real environments. These simulations can generate thousands of data points quickly and cheaply. Once trained in simulation, models are adapted to real-world settings using techniques called sim-to-real transfer. Another approach is self-supervised and unsupervised learning, which lets robots learn from raw sensor data without needing humans to label everything. Robots can learn to recognize objects or navigate by exploring and interacting with their surroundings on their own. Combining deep learning with traditional robotics methods, like probabilistic models, helps improve reliability and reduces data needs by using prior knowledge and handling uncertainty better. Transfer learning and few-shot learning are also important. They allow models to apply knowledge from one task to another or learn from just a few examples, saving time and data. Active learning is another tactic where robots ask for the most useful data points to be labeled, making data collection more efficient. Even with these methods, deep learning in robotics still relies heavily on large datasets. It's not yet fully able to operate with minimal data, but progress is steady. Many advances in autonomous cars, drones, underwater robots, and robotic arms come from combining big data, simulation, and clever learning techniques. Overall, deep learning is moving toward reducing the huge data demands, but it still depends on lots of diverse information to perform well in real-world situations. The field continues to find new ways to make robots smarter and more adaptable without needing endless amounts of data.